Hi Year 9s and welcome back to Geography. We're now on to lesson 4 of our glaciation topic, and before we start I would like you to complete this starter task quickly. So you're going to have a look at this cartoon and I'd like you to work out what the message is in there, please. So you can pause and do that now. So we're on to lesson 4 of our glaciation topic, and your title for today is How Are Landforms Shaped by Glacial Erosion Part 1. So you can now pause the video and write that down along with today's date, please. So last lesson, you looked at how glaciers eroded material around the glacier, how it transported that material and deposited it at the end. Today we're going to have a look at the landscape or the landforms that are left behind by all those processes. So today we're going to identify and describe glacial erosional landforms, such as quarries, tarns, arêtes, and pyramidal peaks. So now we're going to take a closer look at these landforms and how they're formed. During glacial periods in the last ice age, ice caps covered mountainous areas. River valleys were slowly filled by moving ice, which straightened and deepened them. Diagram A shows how such landscapes changed in 3 stages: before, during, and after. So if we have a look at these diagrams, we can start to notice changes. Now, before glacial periods, we can see that these areas had steep valley sides represented by those V-shaped valleys, with a narrow channel in the edge with steep sides at either side. Okay, we can see that across the mountains or down the mountains, we can see some small valleys. Now, during a glacial period, most of this mountainous areas gets covered in snow and ice, represented by that white area. We can see that that V-shaped valley has now been widened. Now, as that glacier moves along that valley, it's going to erode some of that bedrock material. It's going to pick it up and transport it as it goes. It's going to get wider and it's going to get larger. You can also see some deposited material right at the bottom of that U-shaped valley. What we're starting to see are features of this landscape on the mountains as well. So if we look really closely at this during diagram, we can start to see arêtes, which are those sharp areas of the mountain whereby 2 quarries meet either side. Okay, and we can see some truncated spurs that are left exposed. Now, after this period, so when the ice has melted and the glacier has shifted, we can see that we're left with some really prominent features. So if we look carefully at the after diagram, you can see a pyramidal peak right in the middle of that mountain. And that's formed because some of the area around the side of that mountain has been worn away or eroded by that material. We can still see the arêtes, those sharp areas of the side of the mountain, and we can see those quarries, those kind of indentations on the mountainside. We can see hanging waterfalls along the side of a U-shaped valley, and this is where snow and ice melt will fall down the sides of the valley into the channel below. Right, Year 9s, we're going to go on to our first task now. So using these diagrams, I would like you to describe how a landscape can change during and after glaciation. You can use these diagrams to help if you would like to quickly sketch them, because that always helps in describing what we're trying to say. Give yourself no more than 5 minutes on this task. So if you do want to do sketches to support your description, then keep them as simple as you can. You can now pause for 5 minutes. So now that you all understand glacial landforms, you're going to move on to your next task now. What you're seeing on this slide is an OS map extract of Snowdonia in North Wales, so quite a mountainous area. I would like you to look carefully at the contour patterns on this map to identify some of our glacial landforms as mentioned previously. Now, you're going to need to read those contour lines. First of all, you need to make sure you know what that is. So our brown lines on our map are our contour lines. They represent 10-meter levels in height. If you see contour lines close together, that means the land is really steep. If they're far apart, it means the land is quite shallow and fairly flat. So the closer they are together, the steeper the land. So you're going to identify 4 features. You may need to skip back to remind yourselves what those features are and to look at the previous diagrams to help you. Okay, you can spend about 5 minutes on this. Try not to spend longer than that. You can now pause and complete that task. Okay, so now we're going to look at one of these landforms in more depth. We are going to understand how a corrie is formed. So a corrie is where a glacier begins to develop as a sheltered hollow on the sides of a mountain. As snow builds up and turns to ice, it starts to flow. As ice builds up in the hollow, the increased weight of ice and movement down the slope leads to the ice gouging and deepening the hollow. The ice rotates as it moves and flows down the slope. After an ice age, a lake may form in the hollow, and this is called a tarn. A corrie has 3 distinct features: a steep back wall, an over-deepened hollow, and a lip. So if we have a look at these diagrams in these different stages, if we look at stage 1, we can see that snow starts to collect in a hollow of a mountainside. Now what will happen is that moisture will seep into the rock and freeze thaw will start to occur. So it will start to erode away and weather that material. Now over time this hollow will get bigger and bigger and the glacier will start to fill and it will start to move. Now if we have a look at stage 2, we can see that material that has been eroded and weathered is plucked by the glacier and transported towards the edge of that hollow. Now in stage 3, okay, in a non-ice age period and non-glacial period, or as we call them, interglacials, we can see that the glacier has melted and it's formed this tarn, our glacial lake, or a corrie loch as it's often known. We can see that material that was plucked by the glacier has now been deposited at the end of this hollow and it's formed a rock lip. Okay, we can see some freeze thaw weathering scree, which is loose material that sits on a mountainside, and we can see we're left with our steep back wall. All right, Year 9s, your task now is to pause this video and watch this YouTube video. And this shows you some footage of corries and tarns in North Wales. So please, I would like you to type this in and have a watch of this now. It's only a few minutes long and then you can come back to the PowerPoint. All right, Year 9, so well done for watching that video. Your next task is to have a look at this photograph of this corrie in Snowdon Peak. I would like you to sketch this photograph of this corrie. Okay, so a bit like our field sketches that we used to do. Okay, you do usually the background first, then you might want to do the middle ground and then the foreground. So try and do it in stages if you can, just to show the layers and the depth of that picture. When you've done that, you are going to label the 3 features of a corrie. 1, 2, and 3. You may need to skip back to the previous couple of slides to help you with this. And remember that we looked at those photographs or those diagrams in stages. That will help you identify these features of a corrie. Again, give yourself about 5 minutes to do this. If you need to take a bit longer, that's absolutely fine. Okay, so you can now pause the video and complete that task. All right, Year 9s, so on to our next glacial landform. So we're now looking at arêtes and pyramidal peaks. Now where 2 corries develop side by side, the glaciers erode the rock between them, leaving a knife-like edge called an arête. When 3 or 4 corries develop around a mountaintop, a pyramidal peak is formed. Okay, so what we're seeing is as that ice gouges those hollows out of the landscape, that slither of land that's left in the middle becomes really, really narrow and really, really steep. And over time, this helps to create the peak of this mountain, known as a pyramidal peak. So your last task for today, Year 9s, is to either draw a sketch of these arêtes and pyramidal peaks Or you might like to use the internet to find a picture similar to this one that you can copy and paste into your work or draw from that. I'd then like you to annotate your sketch to explain how these features are formed. Okay, so remember that an arête is formed when two quarries are side by side along the mountain. Okay, now remember that also annotating means providing information. So I would like more information than just labels. Okay, try and put as much detail down as you can on your diagram. Don't spend any more than 10 minutes on this task, please, Year 9s. Okay, so you can now pause and have a go at this one. All right, so what we're going to do is we're going to mark one of your previous tasks now. So I would like you to come back to your notes where you identified the 4 features on your OS map. We're going to go through that now. So number 1, if we see those contour lines meet as a kind of peak, okay, we can see they're all really close together, which means that that land is really steep. So this has got to be our pyramidal peak. Number 2, we can see that gouged out hollow where those contour lines wrap around the side of our pyramidal peak. This identifies this as a quarry, and at the bottom of that we can see that there's some water. We can assume that this is glacial melt or ice melt, okay, and this is going to be our tarn left over from the glacial period. And then our last one, number 4, we can see where the contour lines meet, and they kind of create that ridge along from that pyramidal peak, and this is known as our arête. Okay, so give yourselves a mark out 4, correct them if you need to, and that is the end of the lesson, Year 9s. Okay, so well done for doing this, and I will see you soon for lesson 5, part 2 of our glacial landforms.